Hello, and welcome to Beyond the Gates. I'm Annette Kirkland. This season, we're talking about 7 Labs, 1 ERDC. Discover the power of ERDC's 7 laboratories as they bring their technical expertise together to solve the nation's toughest challenges. From developing technologies that support the warfighter to improving the civil work systems we rely on each day, see how each of these 7 labs play a unique role in engineering a safer, better world. We have with us this morning 2 guests, Dr. Martin Page and Dr. Sarah Clark. Dr. Martin Page is a senior scientific technical manager, and Dr. Sarah Clark is a public affairs specialist, and they're with the Construction Engineer Research Laboratory, otherwise known as CERL. Good morning.
Good morning.
Good morning, Annette.
How are y'all this morning?
Doing great. Thanks for having us.
Absolutely.
Fantastic, too.
Well, we're going to start off with the best question. To start off, could you tell me about yourselves, your background, and your specific roles at CERL?
Yeah, thank you, Annette. It's wonderful to be here alongside Dr. Clark for this discussion. I've been working as a researcher at CERL for about 16 years, and I'm currently serving, as mentioned, as a senior scientific technical manager, and that's a position I've held for just over a year now. Before working at ERDC, I received my doctorate in environmental engineering and science from the University of Illinois, and was excited to come and work here. Currently in the SSTM capacity, I'm leading research programs primarily in the areas of water security and biosecurity engineering, which really they represent a small fraction of CERL's overall portfolio that we'll talk about today. And as a part of this broader ERDC team, we're just excited to come to work each day, work hard in the lab in the field, and support the DOW priorities. Really focusing on accelerating delivery of advanced technologies and capabilities, and getting those into the hands of our customers. So I'll pass it over to Sarah.
All right, Sarah.
Thanks, Martin. So I am also equally as well excited to be here. Thanks, Annette, for having us, and to be a guest alongside Dr. Martin Page. That's a pretty big deal. He's kind of a rock star around here. So I am a military brat, so I've been involved with the government for a long time. Before I came to CERL about 10 years ago, I was active duty Air Force, serving in the enlisted corps for about 6 years, and I served with jobs with intel and communications. Once I got out of the military, like I said, about a decade ago, I concurrently started working at CERL as a research assistant, and also embarked upon my graduate studies at the University of Illinois at Urbana-Champaign. So throughout this time with CERL, I've went from a research assistant as a student research assistant to internal communications in about 2019. I was the first strategic communications officer here at CERL. And then once I concluded my PhD in 2023, I popped over to research for a little bit, which was lovely. But about last year or so, external communications job came up, this opportunity, and I was thrilled to be able to return to communications. So here I am, the public affairs specialist at CERL, and essentially what the public affairs specialist role is here at ERDC CERL and across ERDC as well is we're the link to the public, right? So we communicate how ERDC supports the nation, supports the warfighter via news media, social media, the ERDC public website, and more. So I do the range of external communication. So press release, articles, support media engagements. I also conduct facility tours, and really just identifying these storytelling opportunities that highlight our amazing work here, and also our amazing people here as well.
And you get to do a radio show.
Indeed.
Well, wonderful. So for our listeners who might not be familiar with your lab, how would you describe the overall mission of CERL?
I can take this one. So, I'll take this one first. I'd like to hear Martin as well. So overall, we discover, develop, deliver, and sustain trusted engineers' scientific solutions for the built and natural infrastructure. So what does that mean, right? So we use our research and development to support kind of the gamut of things that are needed for the DOW to operate, and also for the nation to continue its operations as well, economically speaking and things like that. So we focus on infrastructure science and engineering on the one side, which is installation support to DOW facilities, as well as locks and dams and things like that across the nation. And on the other side, we've got operational science and engineering. So that's warfighter support all kind of the toys that you see, robotics and additive construction and things like that. So here at CERL, we also have lots of world-class facilities that support that, not only the Army mission for readiness, mobilization, and sustainability, but also to support this research and development that it goes across the nation, across the federal government. So I'll pause there and I'll let Martin kind of chime in.
Thanks, Dr. Clark. I think you really set the table there and covered down on the mission space. It generally breaks down into these core focus areas. We've got the resilient infrastructure for Department of War and national priorities. We've got efficient operation and sustainment of our military installations, and then the warfighter and engineering and construction piece. And these focus areas, they support, DOW and national priorities from the infrastructure perspective, and supporting the warfighter spanning, from the homeland all the way to the battlefield. And in addition, supporting our national economic competitiveness and resilience of infrastructure in the homeland. So again, it's really exciting to work in an organization that tackles this broad range of engineering challenges, developing not only just technologies, but holistic solutions that can affect our customers in tangible ways, keeping them safer, helping their budgets go further, and ultimately, just helping them execute their missions with increased efficiency and quality.
Perfect. So the theme of our show this season is discovering the power of ERDC's 7 labs, united to solve challenges. Can you provide an example of how CERL has partnered with another ERDC laboratory to tackle a challenge that neither could have solved alone?
I've got a few examples here that are pretty exciting. And Martin, Dr. Page, please feel free to chime in with additions or to elaborate. So one of our most kind of recent partnerships would be our team along with our CERL laboratory. So the cold regions lab up in the northern U.S., they're doing amazing research on the Arctic environment, how to figure out how to move troops in and out, to figure out how to feed them, to figure out how to shelter them, all these things. So we're partnering with them to figure out how just to do that. Another exciting collaboration is our additive construction team. So we'll talk a little bit more about additive construction later on in the program. But with additive construction, with 3D printing, we have kind of the whole life cycle of research and development here. So our additive team here at CERL figures out how to build buildings, how to build the infrastructure that we need in austere environments. And then our wonderful geospatial lab, they come in and basically blow stuff up to figure out how these buildings, how they are going to survive in enemy territory, right? So they do ballistics testing and controlled blasts. And they actually did a demonstration in 2023 at Camp Atterbury doing exactly that. So it's pretty neat to see that whole life cycle of a building kind of happen all at once. So I'll kick it over to Martin for any elaboration there.
Thank you, Dr. Clark. And yeah, totally concur. And stepping back just a little bit, like the problems that we work on within ERDC and at CERL, are some of our nation's toughest. They're often large, highly complex problems. So this requires, not just a deep expertise on individual topics, but it requires this sort of interdisciplinary approach that's united around our common mission. And working across ERDC, and that's just part of how we operate. It's an important part of our organizational culture. And our interdisciplinary nature, ultimately, that's a tremendous benefit to the overall mission delivery. I can speak, from some of my personal experiences, just to give some tangible examples of how this works. So in the topic area of water security, I've worked closely with colleagues at ERDC's environmental, geospatial, cold regions, coastal, and hydraulics labs, and on water security topics. I've worked with IPL and GSL on other projects, and it's always a great experience to get these additional experts involved in the projects. But again, just as one example, our operational water team at CERL was designing a new water treatment process that, rather than being applied like within the confines of a water treatment facility where we have a lot of control over the situation, we needed something that could be applied directly in surface water bodies like lakes, canals, or rivers. And for this particular application, we had to develop new chemical formulations beyond like what we would do in a normal water treatment plant, things that wouldn't affect the aquatic species like the fish or the water fleas, but still, have this intended treatment effect. And the environmental toxicity subject matter experts at the environmental lab, they not only helped us rapidly assess environmental safety profiles of candidate chemicals, but they also provide all these insights on how the chemical structures relate to the potential toxicity mechanism. And that really just helped us focus our effort and efficiently down select the best chemicals. And ultimately, this helped us accelerate delivery on an important project going from the laboratory and into field testing very quickly. And to me, that's just one example, again, of how ERDC's interdisciplinary capacity, it really allows us to not only tackle these complex problems, but also, work at the interfaces between conventionally stovepipe technical areas and these interfaces, they're ripe with opportunities for innovation and really advancement in support of the mission. And so this interdisciplinary and interlaboratory nature of ERDC, it's just so important to the work we do.
Absolutely. Well, getting to a very, very important work you do with military. So ERDC's military mission is all about keeping the warfighter safe and giving them an edge. So how do the new materials and construction methods being developed at CERL make a difference for our soldiers?
I think Martin Dr. Page is going to let me go first on all these. Please feel free to talk over me, Dr. Page. So I have two examples that I think are, one for sure maybe flies under the radar as far as how we think of, new and improved and all these kind of flashy things, and that's standardization. So we have a team here called the Army Facilities Component System, and they standardize mill construction. And that's extremely important because we all need to kind of know what we're doing, as well as have standards to provide, safety, for, high levels of safety, make sure that we are building things that protect our warfighters literally. And then also that we have kind of a common, plan, a common kind of construction database that allows for anybody who needs it to access it on the military side. That makes things more efficient, right? So they have this, among other things that they do, they have JCMS. So this database that is an absolute time saver. So it's actually led to an 8-fold reduction in time that's required for these engineer planners to site, plan, design base camps throughout the world. And they're in all the across the world, CENTCOM, EUCOM, all across the contingency landscape. So having this database, this kind of shared standardization program and database for engineers to access is critical. And it really saves time, money, and is also, at the end of the day, safer. Another example is how we're trying to move into autonomous construction. And we've got our robotics for research, our robotics for engineer operations team that works on that. So having this autonomous capability to kind of bridge the gap between existing commercial construction equipment and autonomous capabilities really bring us into the future and allow us to use robotics and autonomous capability to do all the things, increase survivability. It's a force multiplier for sure. Enhance operations, right? So we can terrain shape, build maps, move stuff in disaster kind of environments with robotics as opposed to sending humans out there. And I always say that the robotics operations the science is hard, but the mission is simple, right? Put a robot where a human could save a life potentially.
Right. Martin, do you have something to add?
Yeah, in terms of materials, we have world-class capabilities, really from the bench scale to the field testing and implementation, support, long-term monitoring, and how materials affect structural performance and engineering performance. We discover, design, and improve new materials for resilience against things like corrosion and threats to the infrastructure. And a lot of these lead to just, incredible gains in long-term affordability, ease of use, and then for military-specific use cases, helping our personnel dominate our adversaries in a safer and more effective manner. So you can think about things like advanced coatings on a variety of structures and equipment, or composite materials that are lighter and less susceptible to things like corrosion, while still having the same types of strength and meeting those requirements that we expect, and we put a heavy load on a lot of these materials. And our labs in this space have just done tremendous work in coming up with cost-effective solutions and getting them out there in the field to have real impact.
Right. So, I understand it's a hassle, and everybody knows it's a hassle, and not to mention dangerous to keep trucking fuel out to troops in the middle of nowhere. So how does CERL help soldiers power up their gear on the go so they don't have to rely so heavily on those fuel convoys?
Yeah, absolutely. And I mean, this is reflected in one of the current DOW critical technology areas referred to as contested logistics. Our operational energy and also our operational water teams, they play an important role in helping reduce the logistical burdens, in addition to some of those other capabilities that Dr. Clark mentioned related to, robotic engineering operations and additive construction capabilities. But yeah, circling back to this fuel and water resupply. So on the energy side, we're developing new tools for not just generating power, but also like monitoring. How are we using it in the battle space and building our understanding of those demands so that we can optimize around that improved operating picture. Again, new technologies for generating, but also storing energy at the point of need. And there's all sorts of applications for that on the operational side, as well as, the installation resilience side. But getting at that fuel demand reduction is really important. And then how do we integrate all these new technologies so that they work in a smart manner in an operational environment? That's also a big effort. And I think Dr. Clark can provide some specific examples on some of the energy projects she's worked on.
Yeah, thanks, Dr. Page. So we have several exciting examples, and they're kind of all in different pockets of this operational energy kind of space. So one that we've had kind of an enduring example that we're improving as we go, but it has been kind of one right out of the gate is the hybrid power system from our operational energy team. So years ago, we had, folks come to us from the DOW, the military side, and be like, hey, so we need a way to store extra power because we've found that our buildings, our BHUTs and our command centers are not using all the fuel that we're pumping into them. So we're wasting diesel. How do we not do that? So our team created this hybrid power system, which is essentially a big battery on wheels, right? Where you can hook it up concurrently to the generator that's, pumping, using diesel and to power the buildings, and it stores the extra energy. And then the idea is that eventually you get this battery charged up and you can use less diesel because you're using this battery instead. So it saved quite a bit of energy, quite a bit of fuel. Mm-hmm. And then kind of moving into the new century, the new decade, we're also getting into a lot of other kind of reliable energy, technologies. One is actually a wonderful collaboration we have with one of our industry partners, Lima. They're a company out of Minnesota that works on unmanned power capability with PV panels. And these PV panels are mobile. These PV panels can be put out in the middle of nowhere, and they grab reliable energy from the sun, and then also kind of integrate with other the hybrid power system and generation, things like that. So that is a wonderful technology because it's, like I said, it's mobile. It's able to put on the back of a truck and take it out anywhere. Another one that we're doing, just to provide one more example, because clearly I'm excited about this space, if you couldn't tell.
Right, I can.
I'm glad that's coming through. So another technology that we're actually partnering with Fort Bliss, which is wonderful because we want to make sure that we're putting our research and development and our technologies out into these installations so they can be tested before we deploy them. But we call it an energy node. And what it is it has a hydrogen fuel cell battery. So it's like a little office space that can run on hydrogen that you can make in the field yourself. So it's a really cool technology. And we have two of them right now. One of them are here at CERL, and then another is located down in Fort Bliss at the Innovation Lab. Mm-hmm. The Innovation Lab at Fort Bliss is phenomenal. The commander down there, Colonel Soika, is just absolutely excited about anything innovation, anything operational energy, operational water, all these things, trying to move the force into the modern age, right? Because we're looking at multi-domain operations where we don't quite know where we're going to have to operate, and we got to be ready for that. So places like Fort Bliss, and of course here, we're really pushing the envelope trying to get there.
Making sure a building can survive a blast is so important. Can you explain how CERL is designing walls or testing new materials to absorb that kind of shock? And how is CERL leveraging additive manufacturing like 3D printing, concrete printing to build structures faster and stronger than traditional construction methods?
So I'll start this one off too. That with our additive construction team and our additive construction program here at CERL that I referenced a little bit earlier in the program, they are doing innovation like no one's ever seen. They're absolutely amazing. So they're working on, fabricating and repairing, building the whole life cycle of kind of mobile deployed infrastructure. So the wonderful thing about the program is not only that they're building 3D printed buildings, which is cool in and of itself, but their equipment is mobile. And you can collapse the 3D printer and put it on the back of the truck in a shipping container. That is a huge opportunity for a military that's very, very mobile. And another key aspect of this additive construction team is the use of indigenous resources. So they travel across the world, much as our military would do, and need to use the things that are around them to put within their aggregate to build a building. So we're doing that. We're partnering with several companies in this space to make sure that we're also leaning on industry and how we can integrate that into, this 3D construction space. So specifically talking about how they can survive a blast. So additive construction not only significantly reduces construction time, of course, because it's mobile and you use indigenous resources, all these different things, but they're also figuring out how to make these structures stronger using different geometric shapes, for example, using like a chevron shape on a wall instead of a flat wall, using different rebars, different things that increase the structural integrity of the walls, figuring out how to do this fast, how to make it stronger, while also having less materials, less things that you have to truck out to the field. And I'll pause there and let Dr. Page chime in.
Yeah, I think that was a great summary, Sarah. And I would just add on and kind of tying to one of the previous comments you made about like standardization. As new technologies come to bear, such as this 3D structure printing capability, which is truly amazing, there has to be, engineering standardization of the processes for the assembly of these structures. And our team here has just done a remarkable job in being a leading voice in that, and in collaboration with industry partners, but really bringing the safety aspect and the procedures and the importance of the engineering principles to make sure that as technologies spin up and get out there, that the whole process is being done in a safe manner. And I think that's a really important role that team has played, in addition to all the great demonstrations and capabilities that they've put together in warfighting environments and at our installation.
Well, back in April, for the first time, I got to witness the 3D concrete printing, and I'm not going to lie, it was kind of cool. So it's pretty amazing. Technology nowadays is just amazing, and how important that new technology is. So transitioning to civil works, the U.S. Army Corps of Engineers manage hundreds of aging dams and thousands of miles of waterways. How does this collaborative research done at CERL ensure these massive structures stay safe and strong?
Can I take us on one side adventure before we answer that question?
Please, Sarah.
Awesome. So I wanted to note, and I failed to do so in my excitement to talk about additive construction, that not only buildings in an austere environment are important, but also buildings here at home. So our installation support that we do for DOW installations, and then in some civilian kind of areas as well, is super important. So I wanted to touch on that before we moved on a little bit, but it's definitely in kind of the infrastructure science and engineering space that we call it, which encompasses civil works as well. So is that okay to talk about that for just a second?
Absolutely.
Fantastic. So we do a lot of collaboration to make sure that our installations are up to snuff, because we've got a lot of service members to train. We've got a lot of service members that are working here, CONUS, and we've got a lot of federal civilians as well. So one of the things, speaking of buildings that we were just talking about, is the DOW has, I think it's like 1 billion square feet of building space that we have to maintain. A lot of it is aging. And we just, much like our locks and dams, a lot of this is aging because it was built, back in the day. So we have a team here at CERL called the Building Energy Systems team, where they look at all things building, right? Installation building, like, is it running properly? Is the HVAC working? Are we making sure that if it's a historic building that we are not making it a historic building, or we're not going in there with a sledgehammer? They also work on, cybersecurity and things like that. So our buildings on our installations are super important as well. And then another, just while we're on installation, we have other teams as well that manage the environment part of the installation. Our training and lands team, which kind of mitigates, environmental impacts to our training activities. And then our threatened and endangered species team, which we actually have a ton, and I'm not exaggerating that. We have so many threatened and endangered species on installations. It's actually, I think, more than the Forest Service. It's so many. Mm-hmm. So we have a team that goes around to, all installations and kind of tries to create these like corridors of protection for these endangered species, and figure out not only how do we support the species that are there, but also how do we make sure that it doesn't impact the training mission as well, because we got to train, right? We got to get that done. But a lot of these are also on lands that have, locks and dams that you're talking about, the waterways. So all these things are integrated into making sure that, operations and missions go forward. So transitioning back to the question that you asked about the dams and the waterways, yes, they are getting super old, much like the buildings on our installations, on many of our installations. We've got so many locks and dams that were built around the turn of the century. And I don't mean 2000, I mean 1900, the other century. And they had like a 50-year time frame, which clearly we are well past that.
Right.
So we've got a whole bunch of research happening to, make sure that these structures stay safe, stay strong. We not only have teams looking at what's called fiber reinforced polymer or FRP composite materials for large-scale hydraulic structures. So that would look at the locks and dams, right? How can we continue to get these old locks and dams running and continue to do their job, because a lot of them are absolutely critical to our national economy. But I will pause there. I want to talk about the Peak Technology Center of Expertise, but I've heard my voice a lot. Dr. Page, please take over.
Sure, yeah. I've really been impressed by the contributions our civil works teams make to the infrastructure efforts. And yeah, I think in addition to the great materials work and coming up with new materials I talked about before for replacing existing ones and helping these structures perform over longer terms, being able to monitor and assess is very important. We have experts here that have developed some really great tools for how they can look at, how is the infrastructure performing? How is it aging? Are the materials fatiguing to the point that, we need to prioritize the replacement? And so there's just a whole host of work going on in that space that's really having tremendous impact and supporting operations of that infrastructure.
So that being said, one of the biggest headaches for our local lakes and rivers right now are harmful algal blooms, known as HABs. Why are those such a problem, and how is CERL working to find solutions to this issue?
Yeah, thanks for that question. The harmful algal blooms, so they're basically overgrowth of algae. It's often due to excess nutrients in relatively still surface water bodies. And in some cases, these blooms can span hundreds of square miles, an immense problem. And so this is a tremendous challenge, to many of the lake and water infrastructure managers, and at times limiting or inhibiting access or use of recreational and economic activities. And this can be due to the aesthetics, oxygen level depletions that can result in fish kills, or even presence of cyanotoxins with some types of algae. So through the USACE Aquatic Nuisance Species Research Program, which is managed in the ERDC Environmental Lab as part of the Civil Works portfolio, ERDC coordinates and executes research and development of technologies for detection, prevention, and mitigation of HABs. CERL's operational water team, with our expertise in deployable water treatment engineering, we've played a strong supporting role, particularly in the side of HAB mitigation capability. One of the innovative concepts that we developed in close collaboration with our partners at EL, as well as partners in industry, academia, and other government labs, is called the Harmful Algal Bloom Interception, Treatment, and Transformation System, or Habitats. And it's basically this deployable treatment system that can be moved to a site and start physically removing the harmful algal biomass from the water, along with nutrients that can be inside the algae and really drive that eutrophication cycle. And what's interesting is this system processes the harmful biomass that's taken out of the water, and it rapidly destroys any potential toxins while turning the algae biomass into biocrude fuel. So it's a really innovative project, and again, it's just one example in a broader ERDC portfolio of impactful projects managed by our colleagues at the Environmental Lab, again, targeting these harmful algal blooms.
Perfect. So as we've said, we're highlighting the labs and collaboration across ERDC this season, but outside partnerships are also incredibly important to CERL. Can you talk a little bit about how CERL works with academia and industry to accomplish the mission?
I can start on this one, Sarah, and please add in as I go. So I think first and foremost, we have a very close collaboration with the University of Illinois. Actually dates back to about 1967 when USACE identified a need for a dedicated construction engineering laboratory, and wanted it to be strategically aligned with a university. And so we have this really unique relationship and supporting agreements with the university local to our site here. And it affords CERL and ERDC as a whole the ability to share facilities, collaborate in research efforts, and also, importantly, contribute to the professional development of our staff and students that come and work here. I previously mentioned CRADAs, or Cooperative Research and Development Agreements, in partnership with industry. These are some great tools for close collaboration where industry and government really partner closely together through an agreement in which the industry partner actually provides resources from their own R&D programs in order to accelerate progress in the joint development and testing of new capability. And there are, of course, other important mechanisms for partnering through the ERDC Works page, such as the broad agency announcement and the commercial solutions offerings. And these can facilitate government funding of work in collaboration with for the academic and industry performers. Ultimately, I think working together in partnership with academia and industry, it's really key more than ever to meeting the challenges our warfighters face. And with the tools available through ERDC's Office of Research and Technology Transfer, as well as our ERDC Works partners, we have this infrastructure in place to really do so at speed. Our customers need solutions faster than ever, so we can, so our warfighters can deter our adversaries, dominate the battle space, and this need, there's a parallel track for this, in terms of innovation at speed that applies to our national infrastructure challenges, where, economic and resilient solutions are needed for some of this aging infrastructure to ensure our national competitiveness and resilience. Sarah, did you want to add anything?
Yeah, thank you for that. That was an absolutely wonderful overview of what a CRADA is, and I think that now you need to come in and tell all of our new employees that as well, because that was great. That's something that a lot of people struggle with, like nailing that down. So I'll also add that not only are working with academia and industry is critical to accomplish our mission. I mentioned earlier in the program our work with Lima. To build, operational energy kind of unmanned capabilities. But I also will highlight it is critical when for us to accomplish the mission partnering with other services as well. So kind of getting DOW information we all have, of course, different missions, Navy and Air Force and Army, but working together really makes the mission bigger and the impact larger. And one example would be CERL and Lima. We supported the Navy 4th Fleet unit down in Florida with a demonstration recently where they were looking at how to incorporate, industry, UAS, UAVs, industry technology to support maritime operations. So Lima and CERL went down to the demonstration in Florida and actually provided all of their shore power. And further, it was not only shore power, it was silent shore power, which is critical for operations. If you're going to be doing this in an operational environment, you don't want to have a generator kick on and there you go, your position is compromised.
Right.
So working with the Navy is incredible. We all need to make sure that even though we have our different mission spaces, that we're kind of collaborating within the DOW as well.
Sounds good. And we've only got a couple more questions, guys. And before we begin with these questions, I just want to go ahead and thank you guys for what you do for your community, for the region, and for the nation. It is so appreciated and so important. So thank you, guys. So engineering a secure and resilient future is another central focus of the season. How does the concept of resiliency mean in your laboratory, and how important is it to the research you conduct?
So I think of resiliency as, in kind of really operational, practical terms, as the ability to maintain critical operations in the face of adversity, be that some sort of attack or maybe a natural man-made disaster, maintaining those critical operations. And then, restoring and bouncing back quickly to restore the full operational capacity, not just quickly, but safely. And resiliency, it goes hand in hand with security, which I think of as really more a long-term and strategic side of the same coin. But these concepts are absolutely central to the work we do every day, particularly for the installations where our forces train, support operations, and deploy from and project power from. Continued innovation for these resilient installations and basing, it's really important to ensure that the solutions are not only just technically sound, but also economically viable. As Dr. Clark mentioned, we have a lot of buildings, like the technology solutions have to be scalable, and that's a tremendous challenge as resources become, constrained and budgets become constrained. Like, we've got a mission to accomplish, and we need to optimize the operation, but also not lose sight of resilience and security, which are really central to DOW installations and our end users' needs.
Okay.
And as mentioned, the successful designs and protocols that come out of our R&D efforts, they transition. Sarah provided a great overview of the AFCS, but there's also the Unified Facilities Criteria, which really guide the building design and for our installations and facilities. So it's a very important technology transfer pathway that our laboratory supports.
Sarah, do you have anything to add?
Yeah, I love what Dr. Page said about resiliency. I think that absolutely maintaining these critical operations is what drives us here at CERL and across ERDC. But in short, resiliency is not only surviving today, but also planning for tomorrow, right? We got to win tomorrow. We can't just win today.
Right.
And so making sure that we're prioritizing agility, embracing innovation, all these things that we do across the ERDC, we have to be here tomorrow, right? We can't just go away. So I think that is really critical. Also thinking about, regardless of where we go, we have multi-domain operations, right? You can put us in the Arctic, you can put us in the desert. We're going to figure it out. And that's what resiliency is.
Absolutely. So as you're looking ahead with your crystal ball, are there any key takeaways you want our listeners to understand about the importance of the work being done at CERL?
Yeah, I think Dr. Clark really kind of captured it in the previous question a bit. CERL, along with really the entirety of ERDC, has a dedicated, talented researchers that we're laser focused on accelerating delivery of the mission for both the warfighter and our infrastructure managers and operators. And in addition to making sure we get a good ROI or return on investment for the taxpayer, our multidisciplinary nature that I talked about before, and magnifying that through the collaborations across ERDC and really beyond, across DOW with industry, academia. This provides the footing for tackling our nation's most challenging civil engineering and related problems just head on. Right. And ultimately, it's an honor to be a part of this team.
Fantastic. Sarah?
Yeah, I couldn't agree more, Dr. Page. That is phenomenal. And I think that a lot of the public a lot of the technical details are kind of a lot, but the thing that we want to really be is a little bit behind the scenes, because if we're behind the scenes and your stuff works, or the military operates, then we know we're doing our job. So
Absolutely.
we're happy being the back. Yeah, we're happy being the backbone. We're happy being kind of the framework that provides solutions for our warfighters, solutions for our nation, where things work. And that's enough for us, for sure.
Perfect. Well, thank you guys again so much for being on the show today. It was so educational, and we appreciate you.
Thank you, Annette.
Thanks so much.
Thank you. And thank you for listening to Beyond the Gates. Come back at us next week when we talk to you about another laboratory with ERDC. Have a great day.